Are you Charles Darwin?
Hey, aren't you Linnell?
Yeah.
How do you know me?
Oh, from that show on MTV. Yo, what up? This is my crib.
How do you get this much money?
Theory of natural selection.
What's that?
Well, let's take a look and see.
Hey, what up, Mark? You have to do use and disuse? Yeah, I got it right.
Yo, man, I don't get this.
Yo, just use and disuse. It's just when you use a certain part in your body, it grows bigger, and it gets encrypted in someone's genes.
No, like I get that and all, but I think that like when humans reproduce, like, they reproduce faster than the food around them. So like in a certain point of time, they'll run out of food, and then there'll be overpopulation. You know?
Yeah, I get that, but what exactly is a population?
Oh, population is like individual species in a certain type of area.
Hey, you catch that game last night?
No, how was it?
I was okay.
Whoa, guys. I just made this new theory after 52 years. Natural selection.
What is that?
Natural selection, survival of the fittest. It's the same thing. Well, here's an example. As you can see, Jason is much better than Adele, who isn't very good at anything. From the Galapagos, after my trip on the Galapagos Islands, I discovered these new things called homologous structures. Like a hand of a human and the fin of a whale. They're pretty much just similar structures, right? But they're used completely differently. Like a human hand used for holding things, as a whale is used for swimming. So animals, they go to different places, they have to adapt to their places. So they're similar structures, they come from the common ancestor, but they're used completely differently because they have to survive their environment. From biodiversity, for example.
An example of biodiversity is Matthew, the cool one. Adele, the athletic one. Omar, the the smart one. So what are you studying for, Omar?
I'm studying genetic drift, the tendency of certain genes to stay in a species. What about you, Leo? What kind of theories have you come up with?
Well, the one that I most recently came up with is called uniformitarianism. It kind of goes along with your concept, but it's more geologic based. Basically, that all changes on Earth happen uniformly through time. I've also heard of catastrophism. It's basically the how it kind of contradicts your idea. How animals they like change over time due to natural disasters, like say hurricanes or volcanic eruptions, earthquakes, etc.
Yeah, I think that plays a big part of natural selection. Sometimes who's the luckiest. For example, it's not always about natural selection. Like a catastrophe, it just depends who's in the right place at the right time.
Yeah, so it's pretty much it.
No, it's all about use and disuse. When you use a certain structure in your body, it grows bigger. Just like working at the
What's
gym.
this gene pool that I've been hearing about?
Well, gene pool is the combined genes of the entire population. And another example of evolution, a specific example, is industrial melanism. For example,
Oh, look, it's a white moth.
So Darwin, why is there a black moth now?
well, industrial melanism makes the moth have to change its color. After new machines were invented, there was a lot more soot created, which made the moths have to adapt to the environment because of natural selection. So it's hard for predators to find them because of the camouflage color now.
So Leo, I heard about gene pool from Darwin. What about you?
Oh, yeah, I've also heard of it too. It's basically just alleles in a population.
So what's a micro and a macro that I've been heard about?
Macroevolution is basically evolution above the species level. That it doesn't focus on individual species. It focuses more on, say, formation of mammals or birds, etc. And as for microevolution, it's pretty much the exact opposite. It's small changes from generation to generation. That's what causes the evolution.
So, have you like heard of any other evolution ideas or anything?
I've heard of how evolution can help be shaped by like say bottleneck effect or founder effect.
What's the bottleneck effect?
Bottleneck effect is basically when, say, for example, a natural disaster affects a population in a negative way, and so that population, a huge part of it like dies off. So you're left with a few, and they gradually reproduce, and the population grows back again. The negative thing about it though is that it leaves many. There's very little genetic variation.
Oh, so like it's survival and luckiest, right? Kind of like a genetic drift or something.
Yeah, it's.
So what about the other one you said, the founder effect? What's that?
Oh, founder effect is kind of like the opposite. Basically, a few individuals of a species, they leave a large population and go to a new area, colonize it, and then they help, and then it grows into a large population. But again, there's still the same downside in that there's very little genetic variation.
Oh, so like the gene pool, it totally completely changes, right?
Yeah, because they're probably not good representatives of the original large
Oh, okay.
population.
So always a good factor. Sometimes it's just about who is luckiest.
Dude,